I hit record and I didn't. Yeah.
Oh,
I'm sorry. So I'm recording right now. I just realized right now I thought I had already hit record and apparently I didn't. But let me go ahead and start with a little bit of 3.5. And guys, 3.5 is kind of a short section. There's not a lot in 3.5, and I want to say the homework problems y'all have are pretty they're pretty short. Okay, there's not a
yeah, I
lot.
think I remember. I'm not sure
Yeah,
about
there's not a
how
lot
you
of
did it, but I
yeah,
think I remember.
there's not a lot of homework problems in 3.5. So 3.5, we're talking about rational functions, okay? And so rational functions, let's see. It says a function f in the form f of x equals p over q of x is what we call rational functions. Okay, so guys, the easiest way to describe this is we're going to find these things called asymptotes. And there's things called vertical asymptotes and these things called horizontal asymptotes. Okay, and I'm going to show you how we can go through these. And I think we have probably enough time to get through at least, if not all, most of 3.5. But I'm recording now. Okay, so let me explain the easy breezy cover girl way of doing this here. So let me get my pen here. The first thing I'm going to go over is how do we find vertical asymptotes. So I call them the VAs. Okay, the VAs are what makes the denominator equal to 0. Okay, so I'm going to look at my denominator. Here's my denominator. I'm going to set x plus 1 is equal to 0.
Are you sharing your screen? I'm sorry.
I'm sorry. Yeah, that's my bad. Let's see. I forgot about that, guys. Sorry. Let's see. Here we go. Okay, so yes. Okay, here we go. Okay, so vertical asymptotes, guys, is whatever makes the denominator equal to 0. So I take a look. I'm looking at the bottom part right here. X plus 1. I set it equal to 0. So when I subtract 1 on both sides, I'm coming up with x is equal to -1. So that's going to be my vertical asymptote. I'm just going to kind of erase some of this mess over here. And I'm going to say my vertical asymptote is x is equal to -1. Okay. And I'm going to explain what that part is in a second. And then we have something called horizontal asymptotes. Okay. And there's a way that we can figure out if we're going to have horizontal asymptotes. So horizontal asymptotes, or the HAs, right, is we're going to look at the degree of the top and the degree of the bottom. What I mean by the degree is the exponent here is a 1 and the exponent here is a 1. So when the degrees are the same, what we do is we say, then let's take a look of the fraction of the numbers in front of those x's. Well, this is a 1 and this is a 1, and the fraction here would be 1 over 1. So my horizontal asymptote is going to be y is equal to 1. Okay, and that happens when the degrees are the same. Okay, so if you notice, the directions for these two problems say, let's find vertical asymptotes and let's find horizontal asymptotes. Okay, so let's do the same thing for the next problem, and let's see if we can figure that out. And then I'm going to describe to you a little further down in 3.5, what does that stuff really mean? Okay, so for the second problem here, remember, my vertical asymptotes is what's going to make the bottom part equal to 0. What makes the bottom equal to 0? So I'm going to take a look at the bottom part. 2x minus 6, I'm always going to set it equal to 0. And so let me add 6 on both sides. So guys, give me one quick second, okay? Sorry, I got a little kitty and he was scratching to come inside, so I let him in. All right, so I'm setting the bottom part equal to 0. So now my 6's here are going to cancel. So that's going to be 2x is equal to 6. And then we're going to divide both sides by 2. And I'm going to come up with x equals 3. So my vertical asymptote is going to be x is equal to 3. Okay? Now, we're going to go ahead and find the horizontal asymptotes. So the horizontal asymptotes, remember what we said we're going to do? We're going to look at the degree of the top and the degree of the bottom. What I mean by that is I'm going to look at the exponent here and the exponent here. And because they're the same, they don't necessarily have to be 1, but as long as they're the same, so as long as they're both like 2s or they're both 3s or whatever, as long as they're the same, then we're going to take the fraction of these numbers. So that means that my horizontal asymptote is going to look like this. Y is equal to 4 over 2, and 4 over 2 is just equal to 2. So my horizontal asymptote is y is equal to 2. Okay? That's going to be my horizontal asymptote for this particular problem. Now, let me do the same thing for the third one. Okay? So I'm going to come to my third problem, right? And we're going to do the same thing over again. We're going to say, let's find our vertical asymptote. So remember, the vertical asymptote is what makes the bottom equal to 0. So I'm going to take the bottom piece right here, x squared minus 5. I'm going to set it equal to 0. So when I move the 5 over there, I'm going to get an x squared is equal to 5. Now, because it's an x squared, I need to get rid of that square by taking the square root. So I'm going to get x is equal to plus or minus the square root of 5. So just to point something out here, guys, in this case, my vertical asymptotes, we're going to have 2 of them. One of them is going to be equal to x is equal to the square root of 5, and the other one is going to be x is equal to the negative square root of 5. Okay. Now, just like we did before, we're going to find our horizontal asymptote. Okay. So remember, when I'm going to find my horizontal asymptote, I'm going to look at the degrees of the top and of the bottom. Okay. So what I mean by that is, if I look at the power of x on the bottom, it's a 2. And if I asked you, what's the power of the x on the top? You would say, well, there isn't an x on the top. And I'd say, you're right, there's no x on the top. So when there's no x on the top, we can understand that there is, but the exponent there is 0. Okay? So now the exponents are not the same. The way we figure this out, if the exponent on the bottom is bigger than the one on the top, then my horizontal asymptote is always going to be y is equal to 0 every single time. It's always going to be y equals 0. Okay. And guys, I want to say in your homework, you should not have any where the one on the top is bigger. I tried to pull those problems out, so I don't think you have any like that. If you do, let me know, but I don't think you have any like that. They're either going to be the same or the one on the bottom is going to be bigger. So when the one on the bottom is bigger, it's always going to be y is equal to 0. Okay. So here we go. Let me go ahead and do this problem here. And it says, which choices have domains of negative infinity to 3, union 3 to infinity? Okay, so these here are what we call graphs of rational functions. These are what the graphs look like. So I want you to think about something. The domain refers to the x values, right? And if you notice what we've done is we said, look, we're going to go from negative infinity, so we're going to go all the way to the left. And right before we get to the number 3, we're going to stop. Because the 3 has a parenthesis here, and the 3 has a parenthesis here. And then we say from 3, we go all the way to the right. So what we've done is, wherever the number 3 was, we took that number out. Now, I want you to notice something. If you look at choices A, B, C, just A, B, and C, all of these here have these vertical lines right at x is equal to 3. These are what we call our asymptotes. The graph gets really, really, really close to these lines, but it never, ever, ever touches it. Okay? So it gets really close there, but it doesn't touch the line. So the domain choices that have negative infinity to 3 and then 3 to infinity would be A, B, and C. Those are what asymptotes are. Asymptotes are lines where the graph gets really, really, really close, but it never actually touches it. Now, we had also talked a little bit about horizontal asymptotes. I want you to look here. There's a horizontal line here. That graph gets really, really close to it, but it never touches it. It gets really, really close to it, but it doesn't touch it. This one also has one right here. And this one also has one right here, because the graph gets really, really, really close, but it never touches. Same thing here. So my graph gets really, really, really close, but it never actually touches that. Okay. And let's see. Guys, one thing I want to point out, I just saw this right now as I was doing this here. If you look on choice D, how there's a, there's a circle right there, and if you notice that circle isn't filled in, all of them have domains of negative infinity to 3 and 3 to infinity, because you can never plug in the number 3. The graph will never either touch it, or it's going to have an open point like that. Okay, so all of those there have that same kind of a domain. And then I want to say there's a similar question: which choices have a range of negative infinity to 0, and then from 0 to infinity? So let's see, do we have any of them that have a range like that? Yes, the one that has a range like that would be choice A, because if we notice here, remember the range refers to the y values, right? So I'm coming up from the bottom all the way, and then I have to stop at 0, and then I keep going. So because we have that graph, that horizontal line right there at 0, this graph has the range of negative infinity to 0, and then 0 to infinity. The reasons why like choices C and D don't, because the graph isn't going on down here, right? And the reason this one doesn't is because my line here, if I zoom in, my line here is not at 0, it's at 3. Okay. So that's a little bit about rational functions. Guys, for your homework, the kind of problems you're going to see in your homework are, let me see, give me 1 second. Let's see. Let me see if I can pull that up. Give me 1 quick second. Let's see, 5. Let's see if this thing will load up. Here we go. It's coming, it's coming, it's coming. Okay, here we go. So let me stop sharing this part with you guys, and let me share this screen. Oops, this screen with you all. Okay, so for this is number 2, and it says give the equation of any vertical, horizontal, or oblique asymptotes. We shouldn't have any oblique in your homework. So remember, the first thing I do, if I'm going to find my vertical asymptote, I'm going to take the bottom part and I'm going to set it equal to 0. So let me stop sharing this part with you guys real quick, and let me come back to this. And let's make sure you guys can see it. Yes, okay. So what I'm going to do is I'm going to write the function that I had here. So the problem that I had was f of x is equal to 4 minus 4x over, I want to say it was 6x plus 3. Let me double check it. Yes, okay. All right. So remember, if I'm going to find my vertical asymptote, I'm going to take the bottom part and I'm going to set it equal to 0. So when I move this 3 over, I get 6x equals minus 3. And when I divide by 6, I'm going to get x equals negative 1/2, right? So I'm going to stop sharing this part right here, and I will come back to my problem. And let's see. Okay, here we go. I'm going to do my fraction, and we said negative 1 over 2. And I'm going to check my answer. And let's see. There we go. Perfect. Okay, and now it says, what about my horizontal asymptotes? Okay, so let's see if we can figure out about our horizontal asymptotes. So for my horizontal asymptotes, what I'm going to do is I'm going to do a little stare and compare, right? So my horizontal asymptote. Remember, I'm going to look at the degree of the top. That's a 1. Look at the degree of the bottom. That's a 1. So now I'm going to take this fraction. So my horizontal asymptote will be the fraction negative 4 over 6. And I can reduce that by dividing them both by 2. And I'm going to end up with a negative 2/3. So I will stop sharing this part right here. And I will come back to my problem. And let's see, here we go. I click on this, get my fraction going, and negative 2 over 3. And I will checkity check my answer. And there we go. Right? And is there oblique? No, we're not going to have any obliques. So I'm going to click on part B. There is no oblique asymptote. And guys, just to give you a heads up, the way you would know if you're going to have an oblique is if the power on the top was bigger than the power on the bottom. And I think I pulled those questions from your homework, so I don't think you have one like that. Let me see. Here we go, right? And then this is like a domain, which is the one that has domain. So we're not including the number -1, right? We're not including the number -1, so I would have to zoom in on each of them, and I might even have to do this. And this is not that one, right? So I don't want to use that one. Maybe I would check this one. No. Unfocal. And maybe I'll check this one. No. And maybe I'll check this one. Here we go. Let's see. It's probably going to be choice D because -1 would be somewhere right about, I don't know if y'all can see it or not, but -1 would be somewhere right over here, more to the left. So I'm going to select D. I'm going to check my answer. And let's see. There we go. Right. Next question. Let's see, here we go. In range, right? So I'm going to find the one that has a horizontal asymptote of y equals 1. Looking at this, it might be either B or D. I'd have to go and check again, right? But that's what I'm looking for. So anyway, let's see. I hope that helps, guys. It looks like we're, it looks like we're just out of time. But I'm sorry I didn't get a chance to record everything. I thought I had already hit record, but I didn't. But if you, Vivian, I know you were here the whole time. Fabian, I hope you got to see what you got to see. And guys, don't be shy. If y'all got questions, message me. I'll be more than happy to answer any questions y'all might have. So don't be shy. Okay, if you got a question, send me a message on your mind or on Procto. Take a picture of the problem, send it to me. I'll make a video and I'll send it out to the entire class. Okay.
All right. Sounds good.
Okay. All right, y'all guys, y'all have a good afternoon. Thank y'all for joining. Appreciate it. Happy to answer your questions. So if you got them, let me know. Okay.
Thank you.
Okay. Bye-bye.